Hi students, my name is Dr. M. Abdul Rahman, Associate Professor of Chemistry, Department of Collegiate Education. I am going to discuss in this video the analysis of water, and that this topic is included in the basic analytical chemistry portion of the 5th semester MSc Chemistry, University of Mysore. Here I am going to discuss with the determination of pH, acidity, alkalinity and dissolved oxygen of a water sample. First we will discuss the determination of pH. pH is determined by using pH meter. Commercially available pH meters is used. The pH meter is calibrated with the standard buffers. pH electrode is rinsed with the distilled water and outer side is whipped carefully with the filter paper to dryness. The electrode is dipped in the water sample and pH is recorded. Acidity is a measure of capacity of water to neutralize a base. Acidity is the sum of all acids present in the water sample, strong mineral acids, weak acids such as carbonic acid, acetic acid present in water sample. The principal determination of acidity of water: hydrogen ions present in a sample as a result of dissociation or hydrolysis of solutions are neutralized by titration with the standard alkali. So acidity is determined in terms of the presence of H plus ions in a solution. So acidity thus depends upon the end point pH or indicator used. Dissolved carbon dioxide is usually a major acidity component of unpolluted surface water. In the sample containing only carbon dioxide or dioxide or bicarbonate, titration to pH 8.3 at 25 degrees centigrade corresponds to stoichiometric neutralization of carbonic acid to carbonate. Since the color change of phenolphthalein indicator is close to pH 8.3, this value is accepted as a standard end point for the titration of the total acidity. Determination of acidity of water: for more complex mixtures or buffered solution, fixed endpoint of pH 3.7 and pH 8.3 are used. Thus, for standard determination of acidity of wastewater and neutral water, methyl orange acidity, that is pH about 3.7, and phenolphthalein acidity, the pH 8.3 are used. Thus, in determining the acidity of sample, the volumes of standard alkali required to bring about color change at pH 8.3 and pH 3.7 are determined. The reagent used for the determination of acidity of water: there are carbon dioxide free water sample, standard sodium hydroxide solution of normality is about 0.02 normal, methyl orange indicator solution and phenolphthalein indicator solution. The procedure: first, I have to pipette out 25 ml of the water sample into a conical flask. Then add 2 drops of methyl orange indicator. After adding, titrate the solution against 0.2 normal, the standard solution about 2 normal sodium hydroxide solution. Note that the end point when the color changes from orange red to yellow. Then add 2 drops of phenolphthalein indicator and continue the titration till a pink color just develops, and note down the volume of the titrant used. Also note down the volume of sodium hydroxide consumed for the titration, that is also note down. Next, here calculation: the acidity in milligram per liter as calcium carbonate, that is equal to A into B, where A is the volume of sodium hydroxide solution and B is the normality of the sodium hydroxide solution and V is the volume of the sample, and here A into B divided into 50,000 divided by volume of the sample taken. So that is about the acidity, determination of acidity. Now we will discuss the alkalinity of the water. Alkalinity of a water sample is a measure of its capacity to neutralize acids. Alkalinity is due to the substances that can cause the formation of hydroxyl ions, which in turn can react with the strong acids. Substances that causes alkalinity are of three types. That is hydroxides like sodium hydroxide, calcium hydroxide or magnesium hydroxide. Carbonates like sodium carbonate, calcium carbonate or magnesium carbonate. Bicarbonates like sodium bicarbonate, magnesium bicarbonate or calcium bicarbonates. So that means hydroxides and carbonates and bicarbonates of sodium, calcium and magnesiums. These causes the alkaline nature of water sample. How this can be determined? The principle involved here is alkalinity is determined by the titration of known volume of water sample against a strong acid using a suitable indicator. Two types of alkalinity are evaluated based on whether the indicator used is methyl orange or phenolphthalein. So first we will discuss the alkalinity due to methyl orange. When methyl orange is used, the color change at the end point is obtained only after hydroxides, carbonates and bicarbonates are neutralized. Hence, methyl orange gives the total alkalinity. So that means it reacts with all. The end point is that shows the reaction of hydroxides, carbonates and bicarbonates. So alkalinity, total alkalinity is the alkalinity by methyl orange. It is alkalinity of hydroxides plus alkalinity of carbonates and alkalinity of bicarbonates. AO, AT is equal to AO is equal to AH, AC and AB. These hydroxides, carbonates and bicarbonates. Next, determination of alkalinity here in this case due to phenolphthalein, APH. When phenolphthalein is used, the color change at the end point is obtained after hydroxide carbonates are neutralized and before neutralization of bicarbonate occurs. Hence, alkalinity due to phenolphthalein is due to the hydroxides and half of the carbonates. Carbonates means bicarbonates remains as such. So A of BH is equal to A of hydroxides fully and carbonates only 50%. Carbonates only reacts, bicarbonates does not undergo reaction here. And determination, next the procedure involved is pipette out the water sample, about 100 ml of water sample in a conical flask, add 2 drops of methyl orange indicator and titrate the solution, titrate the water sample against hydrochloric acid, standard hydrochloric acid. This means we have to hydrolyze standardized hydrochloric acid till the color changes from yellow to orange. Let the volume of HCl consumed in this titration be V1 ml. Now next, pipette out 100 ml of this water sample into another conical flask and add 2 drops of phenolphthalein indicator and titrate against hydrochloric acid, standard hydrochloric acid till the color changes from pink to colorless. And here the volume be consumed. Let be V2 ml. Now calculations. The total alkalinity AT, that is equal to AM 50 into V1 into 0.02 into 10 to the power 6 divided by 1000 into 100. That is gives 10 into V1 ppm of calcium carbonate. Next, alkalinity due to phenolphthalein is 50 into V2 into 0.02 into 10 to the power 6 divided by 1000 into 100. That is equal to 10 into V2 ppm of calcium carbonate. So in this way, alkalinity can be determined. Next, determination of dissolved oxygen of water sample. The principle involved here is the dissolved oxygen forms a biochemical that forms the reaction of biochemical oxygen demand, which is an important parameter to evaluate organic weights in water sample. The principle involved in this reaction or involved in this determination of dissolved oxygen here is an alkaline manganese sulfate solution or Mn2 plus ions are added to an alkaline water sample. Here it forms manganese hydroxides where the oxygen state is Mn plus 2, and this, when it is treated with the water solution, here the oxygen reacts with Mn2 plus and it then oxidizes. Here nascent oxygen is formed and it forms Mn4 plus basic manganese oxide, and this main manganese oxide releases nascent oxygen, and plus 4 states to it come back to the plus 2 state of manganese sulfate, and then it releases nascent oxygen, and this oxygen reacts with the potassium iodide. It liberates iodine. The liberated iodine reacts with the sodium thiosulfate to form sodium iodide, and here the liberated iodine is titrated against standard sodium thiosulfate solution using starch as an indicator. The reagents used for water sample, the reagent used for the determination of dissolved oxygen of water samples is the water sample, and then manganese sulfate solution, alkaline potassium iodide solution. Here this alkaline potassium iodide solution is prepared by solution of sodium azide, potassium iodide and sodium hydroxide. Sodium azide is used to remove some nitrites present in the water molecules, waters. And then the reagent is concentrated sulfuric acid, and standard sodium thiosulfate solution of normality is about 0.025 and starch indicator. The procedure is pipette out 200 ml of water into a glass topped bottle, add 2 ml of manganese sulfate solution followed by 2 ml of alkali iodide azide reagent. Mix it well and allow the precipitate to settle. Next, add 2 ml of concentrated sulfuric acid to dissolve the precipitate. Titrate the liberated iodine against standard sodium thiosulfate solution using starch as an indicator. And then repeat the titration to get the agreeing values or concordant values. Now the calculation part is normality. As we know, normality into volume of oxygen solution, that is equal to normality into volume of sodium thiosulfate. V1N1 is equal to V2N2. So that is normality of, therefore normality of oxygen solution. Normality of oxygen solution is equal to normality into volume of sodium thiosulfate divided by normality into volume of sodium sulfate divided by volume of oxygen solution. So here normality of the oxygen solution. So that is equal to N into V divided by 200. 200 is the volume of the oxygen solution taken. Water sample is taken. So the value approximately, the value will be A. If A is the normality of the oxygen solution, then mass of dissolved in oxygen per liter. Mass per liter can be calculated as normality into equivalent weight per liter. So A into 8 is the equivalent mass per liter is per 1000 milligram per dm cube. So this value obtained is the amount of dissolved oxygen present in a water sample. So in this way we can calculate the water sample. So in this video we have determined the acidity, determined the pH, acidity, alkalinity and dissolved oxygen of a water sample. For more reference, the books are Engineering Chemistry by Jain and Jain, Instrumental Methods of Chemical Analysis by Gurudev R. Chatwal and Anand, Chemistry for Engineering Students by Dr. B.S. Jaiprakash, Professor R. Venugopal and Shivkumaraya and Dr. Pushpa Iyengar.